Welcome back. This time we're going to cover the processes of sketching two-dimensional shapes, extruding them into parts, and then removing material to achieve the desired shape. You can see we're picking up right where we left off from the tour. This is still part 4. I haven't saved over it with any new name. We don't have anything in the graphics area. It's completely blank. There's no features in the design tree. This is exactly what you will see if you start from a brand new part file. The first step in the process of creating a part is sketching the two-dimensional profile. And now all sketches have to be created on either a plane or a surface. Surfaces will come more into play once we've already created that initial extrusion. So we can either cut things out of that surface or we can build things from that surface. But since we don't have any surfaces currently in this part, we'll have to start from a plane. Let's go ahead and start from the front plane in this example. You can start from any of these planes and you'll be able to see the reference triad move if you select parts from the top or the right plane. So we'll select the front plane and we'll run up to the top left in our command manager under the sketch tab. We'll select sketch. It's going to pull the front plane front and center. You can have the origin in the middle. Let's start with a center rectangle, something very simple. Now, one thing to note, as soon as I select that, it's got all these options over here that show just different ways that you can sketch a rectangle. The two you'll probably use the most are this one, which is corner rectangle. So if I were to click and drag, it's going to build from the bottom left corner. Or if I go back and select center, you can see it's already adding these sketch relations, which I'll talk about in a second. But if I click and drag, it pulls from the center, and now I have a symmetrical rectangle from that point, which is advantageous when you're trying to center a rectangle on something versus trying to start it from the corner. Anyway, so let's do a center rectangle, and like I was saying a second ago, you'll see it's starting. SolidWorks is trying to add these sketch relations, which kind of off to the bottom right of the cursor, you can see the white box with the line that's saying it's a vertical line. This is trying to add a sketch relation with this point and the origin. If I were to add this, that sketch relation is saying that this point will always be in line with the origin on the y-axis. If I come over to the right of the origin, this one is a horizontal sketch relation, which means it will always be in line with the origin on the x-axis. If I hover my cursor over the origin, I get this yellow box with two intersecting lines. This is coincident, so it is always going to be attached to this point, which in this case means it's at the intersection of the x and y axes. So I'll start from this point for now. I've created this arbitrarily sized rectangle, and you can see all of these lines are blue. This means it's underdefined. That also shows up in your status bar down here. It says this is underdefined. But also in your tree, you can see there is a parentheses with a dash in it. That is another indicator that your sketch is underdefined. There are also two types of lines that you're seeing currently. You see these blue, thick, solid lines, and then these dotted lines in the middle. These dotted lines are called construction lines, and essentially you can use them as a way to make relationships between these solid lines without using dimensions or sketch relations. So in this case, these two lines are holding this rectangle symmetrical around the center, and we can use those in different capacities, but it's kind of on a case-per-case basis. So you'll notice, like I said, this rectangle is blue. It's not fully defined. I can change the location of these points. Any sketch that we're going to be extruding needs to be fully defined. To do that, in this case, I need to add dimensions to this rectangle. So I'm going to do this by going up to the Sketch tab in the Command Manager, selecting Smart Dimension. When I hover over a line and select it, it will pop up with a dimension, and then once you click, it'll give you an option to modify that dimension. So I can just type in 5, hit enter, and now my rectangle is 5 inches wide. So say I wanted this to be a square, I could just run up here, select Smart Dimension, and dimension this leg to also be 5 inches, and I would have a fully defined square. If I go ahead and hit Control Z to undo that, yes, that does apply in SolidWorks, or I can just delete the dimension. I can also accomplish that by using sketch relations. So if I select a sketch line and I hold Shift or Control and then select another line or point, this can be done with 2 points, 2 lines, a line and a point, pretty much any sketchable feature you can add sketch relations to. So when I do this, come over here to your tree under the Properties tab, and I have all of these relationships that I can add: horizontal, vertical, collinear, which just means they would be on the same line. It is not applicable in this case because we need these to be perpendicular. We don't need to add a perpendicular sketch relation, that's kind of already baked in. But one thing I can do, instead of having to have 2 dimensions that I need to change every time I want this square to change sizes in the future, I can just come over here and add an equal sketch relation. So now we have a sketch relationship between these 2 lines. This line and this line are equal, and then we have our 2 construction lines that are in here holding a symmetrical relationship. So by changing 1 dimension in this case, I can change this to a 10-inch square, and it changes all 4 sides. Now, we can see we have a fully defined sketch. You can see that down here in the status bar. You can also see that in the tree. There's no longer that parentheses with the dash in it. So let's say I'm happy with this shape. It's fully defined. I want to extrude this 10-inch square. We come over here near the task pane, and we have these 2 options. We have a Save Changes and Exit button and a Discard Changes and Exit button, and those do exactly what they sound like. In this case, I'm happy with it, so we're going to save it. Alright, we have sketch 1 in the tree. We can see it here just under the origin. It is the first feature in our tree. And it's fully defined since we can see that there's no parentheses with the dash. If I wanted to take this shape and extrude it into a 3-dimensional object, I can come to the Features tab, select Extruded Boss Base, and then select the sketch. Alright. Now it's saying we can either extrude it from the sketch plane or any number of other options, which may be advantageous to use in the future, but for now we're just going to extrude it from the sketch plane, which in our case is the front plane. It's asking us the direction, which this is a blind extrude, meaning it is blindly going to extrude this shape or this profile 0.1 inches in the direction it's dictating. You can see that based on the arrow in the graphics area. You can also use what's called a mid-plane extrude, which now the front plane, it's tough to see because there's only a 0.1 inch thickness, so let's make this like 10 inches. You can see the front plane is in the middle of the part. This can be really nice whenever you get into assemblies later on and you want to make things symmetrical. Having planes in the middle of your parts is actually pretty helpful. But for now, we can just do a blind extrude, and you can see that it's extruding from where that sketch is, and it's just extruding it 10 inches in this direction. If I wanted it to go the other direction for whatever reason, I can click this reverse direction button, and it's going to now extrude it the other way. So if we're happy with all of our options that we've selected, we can just hit this check mark, and now we have a 10 by 10 cube. 10 by 10 by 10 cube. Now let's go ahead and do this process for an extruded cut. Let's say we wanted to turn this into a dice or something. let's just make it, we'll just do one side and we'll make the one since I'm being lazy. So like I mentioned earlier, every sketch has to start on either a surface or a plane. In this case, I want to extrude off of this surface. So I can select the top of this cube and I can start a sketch on the top of this cube. It's going to pull the cube kind of front and center just like you did with the plane. We can select any of these shapes. Let's do a circle since we're making a die. Now I have a circle. You can see it added that coincident sketch relation with the origin just like we did with the rectangle earlier. Now all I need to do is add a diameter to this circle. So we have a 10 by 10 cube. Let's just make the circle a 2-inch diameter circle. That seems about right. Same scenario, I'm happy with the sketch. Let's save and exit. Now we have a sketch on the surface of this cube that we've extruded. What do I want to do with it? I want to make a cutout. So we can go back to the Features tab, select, we can do this the way I did it earlier by selecting Extrude and then the sketch, or you can do this by selecting the sketch and then selecting Extrude, and I think that actually works a little bit better. It's a little bit faster. But you can see it's saved our settings from the last time. So we have a blind extrude 10 inches. Well, this is a die, so we don't want a hole all the way through this cube. So let's change it to maybe 1/4 inch, which is still, I think, extreme for a die, but it'll serve the purpose in this case. So you can also see, if you were to click this drop down, we have a few more options that you'll probably use a lot. You can have the through all button, which this does what it says it does. It just extrudes it through all. Regardless of the thickness of this extrusion, it's going to cut the entire thickness of this three-dimensional part. And some of these will make more sense in a context when there's multiple features on a part. Like up to next will cut it to the next surface it encounters. And up to surface will allow you to select a specific surface if you want a hole to go like the full depth of a part up to a certain point. But for now, we'll just do a blind cut extrude 1/4 inch, and we're happy with that, so we can hit the check mark. And now we have a 1/4 inch deep hole right on the top of this cube. Once you've done all this, and you should probably be doing this a lot more frequently, but I'll just go ahead and run you through it. You can just file, save, and select where you want it to go. I'll just throw it in this folder for now, type in whatever you want to call it. And now your part up here will be saved. You should probably do that immediately. But one other cool feature is you can click on these features in your tree and rename them. Down here with right click, rename tree item. I can just call this, like base or something. Something so that if you have a lot of these features in a part, it may be kind of confusing to know which piece is which. So I may want to name this cut extrude 1 like 1 or something, so I know what side it is. Alright, so let's go ahead and I'll just kind of work through an example part from start to finish from a drawing to a three-dimensional part. And I'll probably go a little bit faster on this one, not do as much describing, but I will talk through what I'm doing and what I'm thinking as I go through it, and maybe that'll give you an idea of maybe what to expect from your homework and maybe just from working in SolidWorks in general. So like before, we'll do File, New, we'll select a part. Alright, brings up part 2 is unsaved. Let's go ahead and look at the part I want to make. So my first impressions are that this is, some sort of rectangle to start out with. It's got a 1/2 inch thickness, 4 by 2.5. It's got a couple holes in it up in these top corners and this rectangular shape cut out in the middle. So first thing I want to do is let's start a sketch on the front plane similar to what we just did with a rectangle, and I'm going to do a center rectangle. Remember, we saw that dimension was 4 by 2.5, I believe. 4 by 2.5, I believe. Yes, 4 by 2.5. So I'm going to give my rectangle 4 inches by 2.5 inches, and now I'm going to save this sketch. You can either save this sketch and it will run it back like the way we did it prior, where I can select the sketch and then extrude it, or before I save it, I can just go to features and select an extruded boss, and it will just go ahead and bring me to the extrude menu while saving the sketch as well. So it was a 1/2 inch thick plate. We'll just go ahead and give this a 1/2 inch thickness, save it, and now you can tell I have the base of that part, the base shape, 4 inch by 2.5 inch by 1/2 inch thick part. Alright, next feature that we saw on that shape, or on this bar, was these 2 holes. We'll start with those. They are 1/2 inch diameter, as you can see by this dimension. This 2x just means there's 2 of them. This dimension is dimensioning the size of both of these holes. You can see that they're locating this first one 3/4 of an inch off of the top and off of the left corner. They're on the same vertical line. We can tell that by this dotted line connecting the 2 center marks on these circles. And then they are 2.5 inches apart from each other, center to center. Alright, so let's go ahead and do that. Let's select this surface. That's where they seem to be cut out of based on the drawing. We're going to sketch. We're going to choose a circle. And this part, we can kind of just put them wherever we want to. Right, so remember what I was talking earlier about with sketch relations. I have these 2 circles that are independent of each other currently. I can move them wherever. They're different sizes. But just from that drawing, I know they're the same shape. So let's go ahead and select the 2 sketches. Hold Shift, select both. And let's make them equal. So now they will be the same diameter. I also want them to be on the same horizontal line. So I'm going to select the center of that circle and the center of this circle, and it's going to automatically kind of pop up with the make horizontal or make vertical relations, all of these, but we want to make them horizontal. So I select that. You can see now my circles, they're the same diameter and they're on the same line horizontally. So if we remember from the drawing, these were dimensioned 3/4 of an inch off of the top. We can do that by just, with Smart Dimension, you don't have to hold select. We can just click the center point of a circle and then come up to the top and select the edge of this rectangle. And now we're going to define the distance between those 2, which in our case is 0.75. Just add that in there. You can see the other circle on the right actually drop down with it because they are on that same horizontal line. I also need to constrain it in the vertical direction. You can see, or actually that is the vertical direction, sorry. I need to constrain it horizontally. I can move these either way. So let's select Smart Dimension again, and let's select the edge of the rectangle that it referenced it off of, and the center of the circle. And in the drawing, that was 0.75. Now, I also need to define the spacing between these 2. And this is kind of where design intent comes in, and we'll discuss that more in the future. So you, just by looking at this drawing, these circles, they look symmetrical. You may be tempted to just come over here and dimension this circle 3/4 of an inch off of this side, because that would be symmetrical. But we want to honor the design intent of this part. These 2 holes are dimensioned at 2.5 inches apart. So since that specific dimension is called out on the drawing, I'm going to model these 2 holes 2.5 inches apart. because we need to hold that dimension that it calls out on the drawing. So select the two centers of a circle. Again, with Smart Dimension, you don't need to hold down select, you can just click them. And that is 2.5 inches. My sketches are still underdefined. What are we lacking? That would be the diameter in this case. And I believe they were 0.75 inches in diameter as well, but that seems too large now. Right, 2 times 0.5. Always check your drawing. Alright, 0.5 inch circles, we have two of them. They are now fully defined. They're dimensioned based on they were on the drawing. We have the leftmost circle 3/4 of an inch off the top and the left. These two circles are now horizontally aligned, and they're spaced 2.5 inches apart. These circles are the same diameter. So I move back to the features, and let's do an extruded cut. And this is kind of where that through wall can come in. You know, we can look at this part, and this actually isn't a great drawing because typically a depth would be called out on this, or you'd be able to see the full depth of the cut in this part here on the side view. But we'll just go ahead and assume they go all the way through the part. So instead of, having to remember the thickness of my material, I can just say through wall and not worry about it. Now I have two holes through the two corners of the part. Now we still have this middle rectangle, which again, it is dimensioning. Everything seems to be measured off this left side of the part. They're kind of using this as a datum. So we're going to just sketch exactly what we see on the drawing. We're going to select this face just like we always do. In this point, I'm actually going to use a corner rectangle because, like I said, this time I'm going to be able to align this corner with the bottom edge of the part. And that just gives me, it's a little bit easier than kind of guessing where a center rectangle would be. So we've already, defined this bottom line as being on the same line as the bottom. So one of these lines is already fully defined, and that's faster. It's off to a faster start than we would have been with the center rectangle. Alright, so we have this cutout is an inch off of the bottom edge of our shape. So I can select Smart Dimension, bottom edge, top edge of the cutout. Let's make that an inch. Alright. The drawing shows 1.5 inches off of the left. So now we can pick 1.5 inches there. And then, again, that might be tempting. You're all smart. You might be sitting here and say, oh, 2.5 minus 1.5, sorry. You might say 2.5 inches minus 1.5 inches. Oh, that's just an inch. So you may be tempted to dimension this top line as an inch and achieve the same cutout. You'll achieve an identical part to what's dimensioned on the drawing. But the drawing calls out this line as being 2.5 inches from the left edge. And let me just kind of, I'll run through this extrude cut process because it's exactly the same as it was for the other one. Extrude cut, select yes. Alright, so we have the part that's called out on the drawing, and if you want to, you can actually sketch both of the circles and that rectangle under the same cut feature. I just prefer to do them in separate ones. And when I was getting back to design intent, like I was saying earlier, everything is kind of measured off of this left edge. This just be a quick lesson on design intent. So if I come in here and I want to change the length of this base, and I want to change it from 4 inches to 6 inches, you will no longer have a symmetrical part based on the way we've modeled it. Everything is going to be a little bit off center because we've dimensioned everything off of this left edge, which might be, in the real world, this might be critical. We might need to hold this spacing, which is just something to consider for the future, but we'll go ahead and change the part back to the 4-inch dimension that is called out on the drawing. Sometimes SolidWorks is a little slow. So we'll change it back to the 4-inch dimension, and one thing you'll notice, and I didn't point this out earlier, is when SolidWorks has this little kind of like stoplight logo on a feature or a sketch, you can just go up to that same logo at the top of SolidWorks, click it, and it will rebuild your part to reflect the actual dimensions and changes you've made. So we compare this part to what we see in the drawing, and that looks right to me. Anyway, thanks for sitting through this. We'll get to practicing some of this stuff as well.